mean, it's gonna be like in a minute. I guess be up in a minute, but in 1 minute.
Okay. Yeah, that sounds good. Okay, so part 2, you'll fill us out. Suppose pair commuting sold an average of 45 few phones per minute in 2007. Okay. With a standard deviation 10, they looked at their P-phone sales data and determined they are normally distributed. The sample size of N are taken from the normally distributed sales. What is the shape of the distribution of X? Okay, so actually in the last lesson, it kind of caught my attention, but I don't know if this is like, let me just pull it up. So in lesson 6, I guess I could have asked you about this before. I don't know, just don't open that up. Just go straight here. So I thought it had to be that N had to be less than 5 or greater than 5 for it to be normally distributed. You know?
I think also because it brings up in the first part. I mean the first part of part 1 in the article.
In the current one.
It's a question. It's like the first question. It says, one of the two conditions must be satisfied in order for a sample mean to be normally distributed. That's the two conditions.
The parent has to be normally distributed.
Yeah.
Or that's one of them. Okay, and I found what I was thinking about. So in the old lesson, it said if a parent population is almost normal, then there has to be a sample size of at least 5. I thought it was that if it was normal, it still had to have a sample size of at least 5. So I was like, oh, they're trying to trick us. Like 4 is right under 5. So
yeah.
So yeah. So if it's normal, then it's normal, no matter what. Okay.
And also they tell you that the parent I guess the parent population, I guess
What?
The curve it comes from is normal.
Yeah, that makes sense. So that would be like, it doesn't matter the population size, it doesn't matter the sample size is going to be normal either way. Like if it's big or small. You know what I mean? Yeah. Okay, so the sample size of 40 is taken. What is the shape of the distribution? It is normal.
Yeah, normal.
Okay, so what is the probability that the third x is under 40? Okay, so this is doing that. Don't we have to do the z-score? This is saying that. Hold on just a sec. I need to check something with my husband real quick. Make sure it started. It'll be 2 seconds. Let's try that. Yeah, I'll ask you about it in a sec. Sorry, I forgot something in the kitchen that's on. Okay. So, is less than 40. So we just have 40 as an x, right? And then we minus the mean.
Mm-hmm.
We got -5 divided by 10 divided by the square root of 4, which is 2, which is 5, so it's -1.
Yeah, that's what I got too.
Okay, then we gotta go to the applet. Did you already pull it up in the applet, I'm assuming?
Mm-hmm.
What was it that you got? And I'll pull that up.
0.1587.
0.1587. Okay. So that's a probability, isn't it?
Mm-hmm. Yeah, that you get that sample.
Cool. Awesome. Okay, so then we have the last question. Oh no, it's not. I hadn't scrolled very far, clearly. Okay, the sample size of 4 is taken from the normally distributed. What is the probability that x is greater than 35 and less than 55? So we have to find out the z-score for each of those, right?
Mm-hmm.
Okay, I'll do the one 55. Do you want to figure out 35?
Yeah.
Okay.
Well, I already did it. It turns out that it's one is a -2, the other one's 2.
Oh, okay.
So
So you just minus them from each other. It's just pretty much the middle part then, right?
yeah.
Cool. Way to go. Okay, so did you do 8 already too?
Yeah, actually I did all of them already.
Well, it sounds like I guess we'll just go. Let me just read over them if there's anything weird. Then I can ask you, but so the probability is so that's the same thing. You're just gonna find the z-score for 41 and 49, right? Simple.
Yeah.
And then the sample 25 is normally distributed. And the only thing different with the n changing means that like when you solve for the z-score, the bottom fraction will be different.
Yeah, and like for 8, it's kind of strange to me, but it turns out that the z-score is -2, 2.
Like -22?
No, this is -2, 2, so it's, the same z-score as 7.
Oh, really?
Yeah,
That is weird. Just because the sample size.
yeah.
It's crazy. Interesting. What about 9? Is there anything different about 9?
It's not unusual. I mean,
Oh, it's just 5 divided by -5, isn't it? 1. No, I forgot to add standard deviation in my head, so just kidding. -2. Okay, so 10, the sample sizes. Okay, so for 10, since it's taken from the right skewed, is it not normal?
no, it isn't.
Okay. And then the sample size, the shape is, that would be normal. Okay, I think we handled it. Do you want to start the group quiz or should we wait for Bran?
Let's wait a little bit more. I
Okay.
guess he was like in another group project.
Oh,
Getting
poor
done.
guy.
Yeah, busy. Yeah, the last couple questions are pretty much the same thing as like the first couple.
So 11 would be normal. The theories would be the central limit theorem theory
Yeah.
or theorem. And the large number theorem would just talking about how the means would be similar or not.
Yeah, I think
Okay,
so.
13. The sample size of 4 is taken, right screwed. No problem. So we couldn't compute the normal probability. We couldn't compute the probability because it's not normal. And the applet is for the normal one.
Yeah, that's correct.
Woohoo, okay. And sample size is 36. It's taken from the right skewed cells data. What is the probability as observed x is greater than 36.5? And then we would just solve for that. I'll
Mhm.
do it since we have time. 36.5 minus, what's the mean? 40. Divided by 10, divided by the square root of 36. It definitely keeps me up on like my mental math here, not having a calculator. I feel really smart when I can do it. I'm like, oh, 10 divided by 6? Awesome. Okay, so negative 3.5 divided by this 1.8. So, did you always love math when you were growing up since you're going into physics?
I didn't really.
Good answer, that's cool. So when did you start loving physics or decide that you wanted to do physics?
Um, I took a physics class in high school, last year in high school, so
Uh-huh.
did a lot.
And you're like, this is pretty cool, I like it.
Yeah.
Oh, cool. So negative 2.01. Oh, that's, oops. Okay, so greater, okay, so greater than. For number, let's see, for number 14, did you get 0.022 by chance?
No, I didn't.
Oh, no. Okay, let me see. So 36.5 minus 40, right?
Which part of the graph did you do?
Just the top of the blue? Or the very top part?
Oh, I think you might need to do the middle part as well, and the top part.
Oh, but I was talking about 14.
Yeah. Let's
No,
see.
oh, you're so right. I get it, because it was a negative z-score.
Yeah, it's on the other.
Okay. Sorry, thank you. Let me click on it then. Let's see. So I got 0.9778.
Yeah. I got a
Still
point
no?
599. It's close now.
What was the z-score that you got?
Oh, let's see. Hold on. I did z-scores on the Excel sheet.
Oh, that's so smart. Do you use Excel often?
Oh, well, not that
I think
often.
I actually asked you this last time and you said just for statistics.
Uh,
No?
let's see. It was. What was it? What were the numbers again?
It was 36.5 minus 40, which is the mean. The standard deviation. Oh, you know what?
I got negative 1.75 for
I
the
think.
z-score.
Oh, I was using the wrong standard deviation. My bad. So negative 1.75 is what I.
Yeah.
Okay. Oh, but now I got 0.9599.
You got a point. Oh, you got a point. 99.
9599.
Oh, yeah, that's close enough.
What did,
I got 0.9599.
0.9599?
Yeah, you got
That's
it.
what I got. Yeah.
Yeah.
That's the exact same I got. Okay. Cool. So I was looking on next week and I did see that there's a review for exam 1. So, oh, and it's actually there in the folder.
Oh,
So it looks like it opens on the 20th of May, so that's next Tuesday.
wow.
Oh, I'm so glad I just remembered. So next Tuesday, this is kind of random, but Monday night, I have to fly to Colorado, and then I'll fly back Tuesday night at like 11.
Okay.
Um, so if we could do it like Monday in the day, if we could just, I guess if we could do it earlier, that would be really helpful. Or I could I have a huge layover in like some random city on Tuesday afternoon if Brand can't do it like Monday earlier if you can't. But yeah, I just remembered that.
Yeah, I'm good Monday or Tuesday. So
You're so easy, Colby, to work with. So great. Cool.
I'm kind of wondering when he's gonna get here, or if he
I
will.
know. I know. I'm like, dude, I can call him or I guess text him.
Yeah, he's been
Here, I
sending.
can.
Like, he said like I'll be there in 5, and then like a little later he said like go ahead and start. I don't know. I guess he
Oh,
hasn't like.
really? Yeah, maybe he's still in his group thing. Maybe, I don't know where I put my phone. Could maybe just say, "Hey, we're about to start the quiz. Do you want us to wait for you, or go ahead, or something?"
I'll send a text.
Okay. Do you want to, I guess, maybe start with a few of the questions?
Okay, yeah. He said he's getting on right now.
Oh,
So.
okay. Great. Just kidding. I didn't know you responded. Hello.
Hey guys,
Hey, how are ya?
good. How are you? Sorry I'm late.
No,
Oh, no.
it's okay.
Chemistry homework, I forgot. Sorry. All right though. Stats was easy. It was pretty easy. I felt like this lesson was not very hard, so
Yeah.
thank goodness. What'd you guys think? Pretty easy?
Yeah, this lesson's, not too hard at all.
Yeah. Okay. That's good. You're taking a quiz right now then?
Yeah, we're just starting it right now.
Okay.
hmm
I'm logging in.
That's totally fine. That's fine. Colby gets the gold star. I got here late too, Brand, so
Oh,
Colby.
thank goodness.
Colby gets the gold star for the day. So
Well done. Yeah, I'm so glad you were late. I was just thinking, I was like, they probably did it without me. It's like, oh, screwed.
yeah, I was just telling him like I totally um totally forgot. Like was just eating pizza, living my life, and then I was like, oh my gosh. I've had this the last like 4 weeks and I just totally spaced it.
I'm so glad you spaced. I feel way better.
Yeah, good. I'm glad that helped out. Colby, if we lived closer, I would like make you cookies someday and be like, thanks. Thanks for waiting.
It's good.
But bummer. Bummer we're across the country. Okay,
Okay.
did you get it open now?
Yeah, I'm ready if you guys are ready.
Let's do it. Okay. So number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z score 1.358 and the left of z score negative 1.358. Round your answer to 3 decimal points. So essentially we just need to highlight the two tails, right?
Yes.
Yeah.
Yep.
0.1358, okay. 0.135. Oops. Did you guys get 0.175? Rounded?
Oh, you said 0.175?
Yeah.
Yeah, I got that.
Okay. Nice job. Pros here. Okay. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but it was raised after a tragic boat accident. The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 71.776 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, than what was observed in this sample. Round your answers to 3 decimal points. Okay, I got it until it said that is extreme or more extreme. Then I didn't know what they were meaning.
Yeah, this is either above or below the mean.
Yeah, like wait. So if it's not the mean, then you're out of luck. As extreme or more extreme means that we're not only interested in values that are lower than the ones we observed, but also values that are far away, as far away from the mean as ours in the positive direction. Huh.
They want to know either or, above or below. And we can make two equations, right?
I guess that would be like, well, I'm just looking at the information we have. We could only calculate for one z-score, right? Which would be the sample mean. So I would think, just more out of logic than understanding what it's asking, we just find the z-score from the sample mean minus the data mean, the population mean, and then just highlight the two tails.
Yes, that's right. I'm gonna move with that.
Yeah.
Yeah, because I just can't even it doesn't even make sense any other way. Like, what would you even do? It's like they tried to make it was such an easy lesson, they tried to spice it up with the wording. You're like, wait, what?
Yeah, really, it's like a stupid question.
Brant, you're a little bit hard to hear, just FYI, but I hear you're mumbling, and I think it's you agreeing, so that's great.
Yes, I'm agreeing if you can hear me.
Yeah, great. I heard you now. I just heard you in the background, like, yeah.
Yeah, still stretching out. Sorry, it's been a long day.
No, you're totally fine. It's okay. Yeah, were you doing another project or just running from class to class?
Yeah, I was doing chemistry homework with some other people that had problems with
Yeah.
it. Like to the lab, kind of.
Hey, what chemistry are you in?
Chem 105.
Chem 105. Chem 105 was my favorite class in college so far.
What? Are you kidding me?
Yeah.
That class is so
If I
hard.
realized that I didn't think it was abnormal to like chemistry. I think if I realized that sooner, I would have just studied chemistry.
Holy smokes, your breed is far and few in between.
No, I definitely studied a lot, so it wasn't like supernatural.
I was gonna say that comes natural for you. You should definitely go into that field.
I know. I actually looked at switching it like last semester, but it would have added so much time on it. I was like, man.
Yeah.
And maybe, yeah, Colby maybe would take more math than me, but I looked at the math and I was like, yeah, I don't think I could do that.
Oh man. Yeah, it's time consuming for sure.
Yeah, but I love tutoring people in it, so bummer that I'm not there that semester. I would have loved to help you out.
Serious, I would have taken you up on that offer.
3.854. Sorry, I'm so slow at doing my math here. Colby, are you already done? You're Mr. Speedy.
Yeah, I have a answer.
That
Yeah, he's
cool
been
thing.
done for like 10 minutes.
Yeah, it's like, guys, don't chit chat, please.
Yeah.
I'm already
right.
done. Okay, so I finally finished it. I got negative 1.92. Is that what your z-score is?
Let's see, 1.92?
1.920, yeah. No? Nobody, no one else?
I got negative 0.277.
Okay, let me go back here and see what I did wrong.
What did you use for the? So you used
So I did.
77.6 for the sample mean.
So what I had done was.
Oh wait, I did it wrong.
That's okay. It's pretty rare. So I did 1.776 minus 185.
Yes, divided by.
I did 26.7 divided by the square root of 48.
Yes, okay. I believe that is right. You got what? 192?
Mhm.
I forgot to divide by the square root of the sample size.
Oh,
Holy.
that will get you.
Yeah, I got negative 1.92.
Okay, so then when I plug that in and I highlight the two tails, I
Okay.
got 0.0549.
0459.
No, 0.0549.
0549. Okay. Wait, so do we round up to make it 0.055? Right?
Oh, because that has to be 3?
Yes.
Yes, you are so smart, yes.
Okay. We in agreement on that? It's positive, right? It's not negative 0.055.
Mm-mm.
It's positive.
Yes. Okay. Good. Just checking.
Yeah, z-scores can be negative, but the area and the probability can never be negative.
Okay. Okay. It's always above the
Mhm.
x-axis. That's right.
Yeah.
Okay.
Which of the following will have a oh, sorry, did you have another question?
No,
We
go
good?
ahead. I was agreeing.
Okay, which of the following will have a smaller standard deviation if 9 observations are normally drawn from a population? The distribution of the individual observations, the distribution of the sample means. This cannot be determined from the information given. Oh, so 9 observations. So they did it 9 times. Okay.
Yes.
I think that. Oh, go ahead. What did you guys think?
I was gonna say, I feel like we don't have enough information.
I think what they're saying is will be the distribution, like, so there's going to be 9 sets of data. And will the data vary more, or will the sample deviation or mean vary more? And I think the sample mean will vary less. Like the sample means are going to be closer than all the random data.
Uh-huh.
Yeah.
Does that make sense?
Yes.
Yeah, because the formula for the standard deviation for a sample mean is the standard deviation divided by the square root of your sample
Your
size.
sample size.
Yes.
Yeah, and like one sample could have one of the outliers, and so clearly it's gonna not be close to the other ones.
Yeah.
Whereas the mean is the average of all of them. So, yeah, I agree. Okay.
So the
Which of the
distribution of sample mean.
Yeah.
yeah, I said the distribution of the sample means.
Okay.
Good.
Okay, so 6. Which of the following results implies that the spread of x decreases as the sample size increases? Or the spread in the mean decreases as the sample size increases. Isn't that the law of large numbers? Anybody?
What is X? Like what?
So x is like the sample mean.
Oh.
Hmm.
Oh, I get what you're saying. Yeah, I would say so.
Hard to say. It's either the central limit theorem or the law of large numbers.
Mm-hmm.
I feel like it's the law of large numbers because it's talking about sample size as opposed to distribution.
Which
Yeah.
which section do they talk about? You know the
It was in lesson 6, and I think it was in the chapter 2 part.
yeah, but they on one of those subjects, the central limit theorem or the law of large numbers, they talked about the standard deviation for like a sample mean. I know the standard deviation tells you about the spread.
Yeah.
So
Yeah, what I remember about the law of large numbers, which doesn't really help us too much, is just saying that I think it was if the sample size is big, then the sample mean is going to be closer to the population's mean.
hmm
That to me, that was the law of large numbers.
hmm
So the central limit theorem is And we just answered something about it up here, right? Or I think in the preparation assignment. So the central limit theorem is that if it's distributed normally, it'll be distributed normally, and then if it is not distributed normally, but there's a large sample size, then it will be distributed normally. So I kind of think which of the following results implies that the spread of the x decreases as the sample size. To me, that I think is a lot of large numbers, and this is just why I'm thinking that. Let me know if it makes sense. But so say we take like 15 different observations of data sets, right?
Mm-hmm.
And in those 15, the larger, if they all had really small data, like only like n of 3 or 4, then their means are going to be all over the place. But if you have a large sample set for each of them, like let's say 150 data points in each, then their means are going to be a lot closer to each other. Therefore, it implies that the spread in the mean decreases.
Yeah.
I just can't think of anything that would make that work with the central limit theorem. You know what I mean?
Yeah,
that
that's
would
true.
explain it. But, so that's my gut, but I don't know. Can you guys see any reasons why it could be the central limit theorem?
I think both of them are explaining the same thing, but one is more explicit. Is that correct?
I remember it in that thing saying, note that they are very different. Like, students always think they're the same, but they're different. And I didn't really kind of wrap my head around why they're different, but I was like, okay, they are different. So I kind of felt the same as you. I'm like, we're talking about the means and we're talking about the sample sizes, so it's kind of in the same ballpark.
Well, if you want, we can skip that one right now and come back to it later.
Okay.
Yeah, fine.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Use the information to answer the following questions. Okay. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal points. So because there's no n given, do we just do 8.8 divided by 8?
Or yeah, they never really tell you it's a sample mean. Yeah, it's only her score, so it can't be a sample mean. So
Oh yeah, that makes sense.
English score.
Wow, my brain just clicked why they're different. Like, oh, sample mean versus a data point.
What are we doing then? 160 minus 150? 0.8 divided by 8.8?
Yeah.
What do you get?
Did you come up with it yet?
Yeah,
I'm putting it in right now.
I got 1.05.
Yeah, and I have 1.045.
Yeah, that's like that too. I just rounded it up.
Yeah, that's right. But we have to put 0.45 because it's 3 decimal points, right?
Oh yeah.
So what is it?
1.045.
1.405?
Mm-mm. 1.045.
Oh, so, okay. Sweet. Above 160.
Okay, what is the probability that a randomly selected student will score above a 160? Oh, so we just have to highlight above 0.1045?
Yeah, I think so.
Wait, so what do we do? Do we plug this in to the graph thing?
Mm-hmm.
So like 160 minus 150.8 divided by 8.8 and plug it in?
Yeah. Yeah, Brant, do that and see, let us know what you come up with.
Working on it. Hey, is the graph thing, is it in group 7? Is it, oh, it's in individual preparation, huh? Okay. Alright.
The website for the graph thing is byuimath.com.
Oh,
Then,
oh,
do you want me to tell you the website, or do you want to look for the link?
oh no, I got it. I found it.
Oh, okay, okay.
I just barely found it right when you were telling me. So, okay. Oh my gosh. So it's not underneath lesson 7?
I don't remember what one it is underneath, actually.
Yeah, will you just give me the website? It's just a picture of it. It's not the real thing.
Sorry, did you say just get the website?
Yeah, would you please? It's just a picture.
Yeah, it's like, byuimath.com
Yeah.
/apps, apps, /normprob, so NORMPROB
Okay.
.html. Sorry, I can't copy and paste it because I have it on my computer and the chat's on another one
No
on my
worries.
iPad.
Oh, okay. I got it. Okay. So, thank you. Just putting it in there. So it's 160 minus 150.8 divided by 8.8. It's giving me a z-score of 1.045, right? 1.005. And the shaded part, I get an area of 0.0800. That's it.
Perfect.
Is that what you guys
Wait.
got?
No, I got a little different. What one did you get, Colby?
I got 0.148.
Yeah. What part of the graph did you highlight, Brand?
The right side of it, just the right side.
The right side. And what was your z-score you put in?
1.405.
Oh, so 1.045 is the z-score.
Oh my gosh. Okay.
Alrighty. So,
Okay, I got it.
yeah, it's okay. Sometimes it takes a second to do all that. Okay, a random sample of 5 students was selected to take the GRE. Their scores are 160, blah, blah, blah. What is the z-score corresponding to the sample mean of those students? Okay, so we have to add these all up.
Yeah, add them up, divide by 5. Okay, I got a mean of 160. Is that what you guys got?
I got, oh wait, I definitely did that wrong because I came up with 65.
I got 160.
So did I. Okay, good.
Is that what you guys both got?
Oh yeah,
Okay.
I got 160.
Yeah, 160. Yeah.
Okay. So then we do 160 minus, what was the mean again? Okay, so 160 minus 50.8. Didn't we already?
Question.
So it's almost like number 7, but instead of dividing by 8.8, we divide by 8.8 divided by the square root of 5.
Divided by 8.8, divided by square root of 5.
Mm-hmm. Do you remember that equation in the individual prep thing, Brand, that talked about like z-score and you do it for the sample means?
Yeah, this is one of those problems then, I'm assuming.
Yeah, because it has the sample, you have a sample mean, so then you
Oh,
have to use that different. I just made that connection a little earlier with Colby, or Colby,
gotcha,
sorry.
gotcha. Okay. But if it's not a sample, meaning you don't, right?
Yeah.
Okay, okay, good, good. Yeah, okay, what,
Yeah, if it's just like one, data point, then you just do it the other one.
okay. Okay,
2.
just a sec, I gotta grab a better calculator. Let me just use my phone calculator.
Yeah, so yeah. Colby, thanks for your patience.
Oh, no problem.
Okay. 0.8 divided by 35.
Wow, we have 15 questions on this one.
Okay, I got the answer is 2.33. Is that right? Or I guess
That's
it
what
was
I got. I got 2.33, and then I think I rounded to 7. Is that what you got, Colby?
I got
2.337?
2.338.
Let me look. Oh man, I just closed my calculator. I'll do it real quick. So we have 8 point. So we got 5 square root. 2. What were all the numbers that you got, Brand? What?
I got 2.3377.
Okay, yeah. So it'd be 2.338 then.
Yes, that's what I got.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Can we just take the z-score and plug it in?
That's what I'm thinking.
Yeah.
Okay. Let's do it, man.
That makes sense. So when we find a z-score for a sample mean, it's essentially saying, instead of saying like it's gonna be more than that data point, saying there's a likelihood that data, like other observations, would be above. Like instead of saying what are the observations that are gonna be found over the z-score, when you do a z-score for a sample mean, it's saying what observations would, like what other sample mean would be found over this. Anybody know what I'm talking about?
Oh. Talking about number 10, right?
Yeah, well, I just like kind of was like, oh, that makes sense. So what they're saying, like when you, like we use this applet for both when you have one data point and like one sample or one observation, or when you have like sample means and you're talking about different sets of samples,
Uh-huh.
you know? So
Yeah.
like when we do it for the sample mean, like we just did, like when we find the probability of something, it's not saying, oh, it's the probability that their score will be higher than this. It's saying the probability that the sample mean will be higher than this.
Yeah.
Makes sense? Thanks for following that tangent. So just kind of change your verbiage and what you're looking for when you do it. Okay. So the area is... Does that make sense to you at all, Brant, or was it a lot of jumbling?
So far, everything makes sense. For now.
Okay, good. So I got 0.0097.
Yeah, I got that.
So just 0.00.
Yes.
Oh, so do we just round that to 0.1?
Well, I think they
0.01?
took the 4 decimal places, right?
Oh, you're so smart. Okay, yeah.
So, yeah, 0.099.
Okay, 11. Suppose that the GPA is 3.5, standard deviation is 0.7, and it's well known that the distribution is less skewed. The sample, a random sample of n equals 81 will be drawn, of 81 students. Uses information. What is the shape of a sample distribution of a random variable sample mean, which represents the sample mean of 81 students? So it's going to be normally distributed, right? Because that sample is bigger than, it's a large sample size.
Yeah, that should be.
Okay. What is the mean of the distribution of the sample means for all possible sample sizes of 81? That could be drawn from the parent population.
Hey, guys. I have a quick question for you guys.
Yeah.
So for 11, it says, what is the shape of the sampling distribution of the random variable x?
Uh-huh.
I said it was approximately normal. Is that what you said?
Yeah. Mm-hmm.
Yeah.
Because they're saying what is the like what, how will that be distributed, because it's a big sample size, it'll be normal.
Oh, okay. Because it's a large number, it makes it normal. Okay.
Yeah, and something that I just started doing instead of saying the random variable x, because it has that little line, I keep having to remind myself that's a sample mean. It's not just like a random x. You know what I mean?
Yeah.
I've started to have to say that out loud, or else I'm like, oh wait, where's the random variable? I don't get it. But it's just saying that it's a sample mean. So, what is the mean at the so number 12? Do you have any more questions on it, or
No.
on 11? I mean.
Nope. I understand now. Okay.
Cool. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
Is it like that question from the last quiz where it's like the like kind of like the overall like mean of the sample distribution? I mean.
Yeah. So like it's pretty much saying if we redrew a bajillion of these, what would be the mean of the means? And it would be the population mean, right? 3.5.
I think so.
Both be the same as the parent graph, right?
Yeah, that's right. That's what I was just, yeah, perfect. I'm like, oh, I had to read it like 4 times before I got that, but yes, I agree. So what is the standard deviation of the sample distribution when the mean of 81 students are selected? Is it going to be the exact same thing? Point.
I think use that formula, right?
Yes. We used the formula we were using earlier, right?
What formula, Kobe? Because the other one's for the z-scores.
There is one that's the standard deviation divided by the square root of the sample size. That
Oh
gives you
yeah, oh yeah, like the bottom of the z-score thing. So it's just going to be 0.7 divided by the square root of 81,
Right.
right? Colby, you're so smart. What would we ever do without you?
not.
Just kidding. Just trying to make you feel really awkward in our group chat here. Just kidding. Okay, so 9.
0.0777 infinity.
Sorry, Bram, what did you say?
Did you write it 0.07 infinity?
Yeah.
Okay.
What was that?
Just
0.0777.
Oh yeah.
Okay.
so are you guys putting in 0.078?
Yeah.
Yeah.
0.07778. 0.0778.
0.07.
Four digits.
No, it should just be 3.
Yeah, 3 digits.
Oh, dang it. I added extra decimals on 12, so it's just 0.35. Okay. Okay, so 14. What is the probability that the mean GPA for 81 students will be less than 3.3? Okay. 3.3 minus 3.5 equals 0.2 divided by... Did you guys get 2.5? Oh, wait, that's the z-score. What did you guys get for the z-score?
Negative 2.57.
Negative 2. Negative?
I haven't solved it.
Oh.
Yeah.
Okay, let me just redo that a little bit. Negative 2.57, right?
Yeah.
Hey, what? Sorry, guys. What is the equation for this to set this up then?
Hold on, just a sec. Oh, interesting. So this would be, so we're looking for the probability, right? And that's what you find in the graph thing.
Yes.
Yeah.
So to find the probability in the graph thing, you need to find a z-score.
Right.
So then for this z-score, you have 2 options for the z-score. One is for means, like the sample mean, if you have a data set like this
Yeah.
of 81. Or the other one would be if they just gave you like a score and that was it, then you could solve it from that. So it looks like this would be the one where you have n divided by this, or you have this like sample mean minus the data population mean divided by standard deviation over the square root of the number. I don't know if that makes sense.
Yeah, makes sense. What did you get for the probability?
Oh, so I got 2 point. Okay, so I got 0.051. Wait, I just typed it in. Hold on. What are we looking for? Greater than 3.3?
Yeah, less than.
Oh, less than 3.3. I did greater. Okay, so I got 9.9949.
9. What was that again?
9949. So
Because I got
995.
0.0051.
Dang it, I looked at the positive side. Okay. 0.0051. Right?
Yeah, that's what I got.
Okay, I got the same thing. Hey, something else too, just to... Well, I guess it doesn't change your answer. Never mind. 0.005 then, right?
Yeah.
0.005. What is... Okay, awesome. What is the probability that the mean GPA for 81 randomly selected students will be greater? So you just take the same thing and you just do the other. Shouldn't it be the exact same probability?
Yeah.
0.005. Oh wait, that's not true. Wait, not true. Okay, so
Ooh.
0.995.
Yeah, so it'd be 0.9949.
Yeah. So 995.
0.995
Yeah, for the last one, yeah.
and 14.005.
Mhm.
Okay. Hey.
So if we go back to 6, do we feel okay with what we put? Do we want to look over?
Hmm. I feel
I think
kind of
we've
like
done
it.
pretty well. So.
I think it probably would be
What?
the law of large numbers.
Yeah, that's kind of what my gut says. Like, I just can't figure out logically how the central limit theorem, like, is very similar, but I don't think it really works for the spread of the sample means.
Yeah. So we'll just go with that
Okay.
one.
Yeah, let's submit it. Huh, we got one wrong.
Really?
Oh, never mind. Nope, we didn't. I thought we did. Perfect. Nice job, guys.
Yeah.
Yay, thank you for waiting. Sorry to you, Colby. Sorry.
Yeah,
No,
Colby, so
no.
sorry. You're so awesome.
I sometimes forget too, so.
Cool. Okay, so Grant, what I was gonna tell you is that Brand, so next Tuesday I actually am gonna be in Colorado. Well, I fly out Monday night and I'm gonna be in Colorado and then I fly back. Like I literally fly in there Monday night and I fly out that afternoon, the next afternoon. And so I'm going to, so like I can't meet at our normal time on Tuesday. So I can do one of two things, like I can do it Monday earlier in the day, or Tuesday, I think I do have a 2 or 3 hour layover in some random airport, and I can do it during that layover. Or I can do it on Monday during the day. Would either of those work for you?
Yeah, either one of those would be fine with me. Whatever will work for you two would be fine.
I think I would prefer to probably just get it over with on Monday, so we don't have to, like, worry about it in the airport. You know what I mean? Trying to catch each other.
That's kind of what I was thinking in case, you have an accident, you can't get internet access or whatever. Maybe Monday might be better.
Yeah.
Yeah, that
So let
would
me
be
just pull up. Let me just pull up really quickly. I can't remember when I leave on Monday.
Yeah.
Um. Yeah, it's just like a really quick little thing. Um. Okay, so this is flying from Boston to Denver. Okay, so it looks like I leave at 5 o'clock Boston time. I'm gonna start work at 12. Okay, so I could meet at like early in the morning. It'd be 10 o'clock your time, Bran, and 9 o'clock your time, Colby.
Yeah.
That's fine.
Or, okay, or I could do it also like once I land, I'm just waiting. I just have like an appointment on Tuesday, so I'm just hanging out so that night. So I could do it later too, like our normal time at night, or like at like 7 your time, Brand, or 6 your time, Colby. Do you guys have a preference?
Let's get it done Monday.
But I mean, like, do you want to do it in the morning or at night?
Oh.
Does it,
Either one's fine.
okay. Does the morning work for you, Brand?
Yeah, I have class at 11:30, so I mean, if we could get it done by 11, that would be totally fine.
Yeah, and maybe what we can do is I'll just have to write a note. But if we really like, we could do the individual prep and maybe look over part 2 so that when we come together, we'll just like breeze through it. You know what I mean?
Yeah, exactly.
Maybe even look over, maybe we can do some of those answers on our own and then just collaborate.
Yeah. Yep, I think that's a good idea.
Okay, I'll set a timer on my phone so Colby, you won't be hanging out here by yourself.
Yeah.
And, and then Monday morning would be awesome. Thank you guys so much.
Yes, thank you guys.
Okay, cool. All right, have a good night.
All right, I'll see you guys Monday.
See ya.
Thanks. Bye.